In our lesson today, we're going to have more practice using graphs to figure out if a relationship is proportional or if a graph represents a non-proportional relationship. Okay, so a couple of focusing questions. What is a constant of proportionality? And what does that constant of proportionality tell you? So in our box underneath, two quantities have a proportional relationship if they have a constant unit rate. A constant unit rate. And remember, we call that the constant of proportionality, and we represent that with the variable k. On a graph, we found out last time that two quantities have a proportional relationship on the graph if it is a straight line. We need to have a straight line, and it starts at the origin. Okay, remember that the origin has coordinates of 0, 0, and it's where the x and the y axis meet. And so we're going to take a look at a graph here in example number 1. Okay, and it's labeled Bobby, and it looks like Bobby is doing some sort of running, biking, doing something. Okay, we can look on the x-axis right here at the bottom and see that that represents his time in hours, and the y-axis represents the distance that he goes in miles. And we can look at this graph and tell that it is a straight line passing through the origin, so I know that this is a proportional relationship. So in question number 1a, they want to know the value of k, the constant of proportionality. Remember that k is y over x, and for the constant of proportionality, the denominator always has to be 1. So we have to find where 1 is on the x-axis. So I'm looking at my x-axis. I can see here's 0, here's 2. So this line right here must be 1 on the x-axis. To get that value of k, I'm going to go up until I hit the line. I hit right here. And now I'm going to come over here, and I'm going to figure out what that value is so that I can fill it in the ratio here. Well, this hits halfway in between 0 and 18, which would be at the value of 9. So in this case, k equals 9, or 9 over 1. This point right here, k, all right, that's at the point 1 comma 9, which in 1b, they want to know, what does 1 comma 9 represent? Well, that's your constant of proportionality, and it means that Bobby travels 9 miles per hour. Okay. 1c wants to know what 0, 0 represents. Remember, that is your origin. Okay, and this means that Bobby travels 0 miles in 0 hours. And that makes sense. If Bobby hasn't started running or biking or whatever it is that he's doing, he hasn't gone anywhere. So in 0 hours, he travels 0 miles. And 1D asks, how many miles will Bobby travel if he runs for 4 hours? So hours was your x-axis. Find 4 on the x-axis. Go up until you hit the line, which is right here, and then we can come over and see that he would go 36 miles. He would go 36 miles in 4 hours. Well, in 1E, they want to know if the proportional relationship continues, how many miles would Bobby run in 12 hours? Well, we know from 1B that he goes 9 miles per hour, 9 miles in 1 hour. So to figure out how far he would go in 12 hours, we would have to do 9 times 12. And if we punch that into our calculator, we get 108. So this means Bobby travels 108 miles in 12 hours. In example 2, we're told that the table at the right shows Allison's distance from the starting line in meters over the first 4 seconds of a foot race. So Allison is running a race, and the data in the table shows her time in seconds and the distance from the starting line in meters. And in 2A, they want to know, is the distance from the starting line proportional to her time? Show your work. So remember, from a table of values, we have to see if there is a constant unit rate. So we're going to be looking for how many meters she can go each second. So looking at our table, we can see that Allison can go 2 meters in 1 second, and that's already a unit rate. Next, we can see that she can go 4 meters in 2 seconds. Simplify it down to a unit rate, and we would get 2 over 1. Next, Allison goes 6 meters in 3 seconds. As a unit rate, that simplifies down to 2 over 1. And finally, Allison can go 8 meters in 4 seconds. Simplified down to a unit rate, we get 2 over 1. Notice that the 4 unit rates are all the same. They all simplify down to 2 over 1, which means that this is a proportional relationship. There is a constant unit rate. So in question 2b, it asks what the constant of proportionality k equals. Well, remember, k equals that simplified value. K in this case is 2 over 1, or just plain 2. All right, so we know we're working with a proportional relationship. Now what we're going to do is graph this data on the next page. Before we graph it, though, in 2c, we need to write the coordinates. Remember, x comma y. X is the time in seconds. Y is the distance in meters. And they've done the first one for you. The first point is going to be 1 comma 2. She can go in 1 second, 2 meters. The next one is going to be 2 comma 4. In 2 seconds, she can go 4 meters. 3 comma 6 is next. She goes in 3 seconds, she goes 6 meters. And finally, 4 comma 8, in 4 seconds, she goes 8 meters. 2D says to graph this data on the coordinate plane on the next page. So we're going to take these 4 points and we're going to plot them on the graph on the next page. So here's our graph. We see over here on the right, it says Allison's run. And notice that the X and the Y axis have already been labeled. They've already been titled. Time is along the X axis. Distance in meters is along the Y axis. And they already have a scale. They counted by ones in each case. We're going to go ahead and plot all of our points. Okay, so the first point from before was 1 comma 2. So from the origin, we're going to go to the right 1 and then up 2. The next point was 2 comma 4. Go to the right 2 and then up 4. Next was 3, 6. So from the origin, go to the right 3 and then up 6. And then finally 4 comma 8. Go to the right 4 and up 8. And now we're going to use our drawing tool and we're going to connect all of those points. Remember that you need to bring your line all the way back until you hit at the y-axis, which is going to hit nicely right there. And again, you can extend through that last point as well. Just don't forget your arrow. So we're going to put an arrow on the end there. And now we're going to take a look at our next question. E says, is there a proportional relationship between the distance and the time? And here we're going to say yes. Well, how do we know that? By looking at the graph? Well, the graph shows a straight line starting at the origin. If you have a straight line that starts at the origin, then you know that you're working with a proportional relationship. 2F says, what does the point 0, 0 represent in words? Well, remember, Allison is running a race. So this means that in 0 seconds, Allison runs 0 meters. That's what the point 0, 0 represents. 2G, what does the point 1 comma 2 represent in words? Well, again, 1 is your X value, so that's your time in seconds. So in 1 second, Allison runs 2 meters. That's what the point 1 comma 2 means. All right, question 2H says that if Allison runs 8 seconds, how far did she run? Well, we know that she can go 2 meters in 1 second from question 2G. So that would mean that in 8 seconds, we would have to do 2 times 8, which equals 16. Allison runs 16 meters in 8 seconds. Example 3 tells us that Allison was running against her friend Carmen. Carmen is a little bit slower, so Allison gave her friend a distance head start of a certain number of meters. The table at the right shows the first 4 seconds of Carmen's run, and so we can see all of that information right here. And what we're going to do in question 3A is list the data points that we're going to put on our graph. So it says list the ordered pairs starting with 1, 4. Remember, your x right here is the number of seconds. Your y is the number of meters. So 1, 4 was the first point. That means that 2, 5 is the next point. In 2 seconds, she goes 5 meters. 3, 6 is next. 3 seconds, she goes 6 meters. And then 4, 7 is the last point. In 4 seconds, she goes 7 meters. We're going to take these 4 points and we're going to put them on this graph underneath the table. So once again, notice that x and y have already been labeled. X is your time in seconds, y is your distance in meters, and we have a scale. We're counting by 1 on each of the axes. So let's go ahead and plot our 4 points. Our first point was at 1, 4. So go to the right 1, up 4. And then 2, 5, to the right 2, up 5. 3, 6, to the right and up 6. And 4, 7, to the right 4, up 7. And now we're going to draw our line. We're going to connect all of our points. Remember, bring your line all the way back until it hits the y-axis, which in this case, it's going to hit right there. And remember, you can extend through that last point as well. Make sure that you draw an arrow at the end. And here is the graph for Carmen. All right, 3B says, how is Carmen's graph the same as Allison's? All right, so here's Carmen's graph. Here's Allison's graph. And we could say that for both of them, both graphs show a straight line. Both graphs show a straight line. Allison had a straight line, Carmen has a straight line. But 3C, how is Carmen's graph different from Allison's? So here again is Carmen's graph. Here's Allison's graph. And hopefully you can see the difference between them. Okay, in 3C, all right, we're going to say that the straight line for Carmen, the straight line does not start at the origin. Okay, remember, we had a straight line passing through the origin in example, in Allison's example right here. But here in Carmen's example, we've got the straight line, but it's not starting at the origin. It's starting right there at that point, which is at 0, 3. All right, and so since it's not starting at the origin, we know here in 3D, where it says, is there a proportional relationship between the distance and the time? No, because the straight line does not start at the origin. Okay, the straight line does not start at the origin. Well, 3E says, what y-coordinate is paired up with the x-coordinate of 0? So we find 0 on the x-axis, and we go up until we hit the line, and it hits right there at 3. Okay, so when x is 0, the time in 0 seconds, she's already 3 meters from the starting line. So what does this point represent in terms of Carmen's run? This represents that Carmen got a 3-meter head start. If you remember at the beginning of the question, they said that Carmen wasn't as fast as Allison, so Allison gave her a head start, and we can see right here, all right, at 0 seconds, she's already 3 meters from the starting line, so she got a 3-meter head start. Okay. Can you tell Carmen's rate of speed in meters per second? So at 0, she's at 3 meters away. At 1 second, she's 4 meters away. 2 seconds, she's 5 meters away. 3 meters, she's 6 meters away, etc. Every second that goes by, all right, Carmen is 1 meter further along. So Carmen is running 1 meter per second. So Allison and Carmen have a friend named Tymesia, and she's going to challenge both of them to a foot race. And the table right here shows Tymesia's distance from the starting line for the first 4 seconds. So we're going to do something similar. We're going to take the data from Tymesia's table. We're going to list the ordered pairs, and then we're going to graph them on the graph underneath. So again, x comma y, x the time in seconds, y is the starting line, the distance from the starting line in meters. We're starting with 0, 0. Next is going to be the point 1, 1. In 1 second, she's gone 1 meter. Next is going to be 2, 3. In 2 seconds, she's gone 3 meters. Then 3, 6, 3 meters, excuse me, in 3 seconds, 6 meters, followed by 4, 10. In 4 seconds, she goes 10 meters. All right, let's go ahead and graph these 4 points. So again, the graph's already been set up for us. So we're going to start by graphing 0, 0, which is the origin right there. Next was 1, 1, to the right 1 and up 1. That was followed by 2, 3, to the right 2 and up 3. Then it was 3, 6, so go to the right 3 and then up 6. And finally 4, 10, go to the right 4 and up 10, which is this point right here. And now we're going to use our line tool. And I'm going to connect my points together. I'm going to extend through that last point, and I'm going to put an arrow at the end of it. And so there's the graph for Tymesia's run. All right, now in 4b, it says to read off the points as y over x and determine if there is a constant unit rate. So again, y over x, so here's our y. All right, so again, there's no data at 0, 0, so we're going to start with 1, 1, or 1 over 1. Okay, that's already a unit rate. Next, the y value was 3 and the x value was 2, 3 over 2. Get a unit rate by dividing by 2. 3 divided by 2 is 1.5. Next is going to be 6 over 3. Divide both numbers by 3 and you get 2 over 1. Finally, we have 10 over 4. Divide both numbers by 4 and you get 2.5 over 1. Notice that the 4 unit rates are different, so there is not a constant unit rate. So in question C, it says, is Tymesia's distance from the starting line proportional to her time? Well, no. The graph is not a straight line starting at the origin. And there is not a constant unit rate. Okay, we can look at Carmen's graph and we can easily tell, yeah, it starts at the origin, but that's definitely not a straight line. And in 4b, we just found out that all of the unit rates were different, so both of those prove that this is a non-proportional relationship. Now, 4d says, how is Tymesia's graph the same as Allison's? So if we go back and look at Allison's, here's Allison's. Here's Tymesia's graph again. And the commonality that they share, both graphs start at the origin. Both graphs start at the origin. But how is Tymesia's graph different from Allison's? Tymesia's graph is not a straight line. Okay, they both start at the origin, but Taimyja's graph is not a straight line. For F, why isn't Taimyja's graph a straight line? Well, it's not a straight line because Taimyja is not running at a constant speed. Okay, and I think that's true for everybody when they run. When you first start running, when you're starting, all right, you're slower than after you've been running for a few seconds, okay? So the longer you run, the quicker you tend to go. So Taimyja's not running at a constant speed. For G, can you tell Taimyja's rate of speed? Well, no. Because Taimyja is speeding up as time goes by. So we're ready to summarize what we've learned today. So in question 5A, it says, which runner or runner's distance to time was a straight line? Okay, so if we remember from before, we had a straight line when we looked at Allison and when we looked at Carmen. Both of their graphs showed a straight line. 5B, which runner or runner's distance to time was not a straight line? Well, that was the last example when we looked at Taimyja. All right, Taimyja's graph had a curve to it. It was not a straight line. All right, in the next example, it says, which runner's distance to time passed through the origin? Where did they start at the origin? And again, that was with Allison and with Taimyja. Okay, but the next example said, which runner's distance to time did not start at the origin? That was Carmen. If you remember, Carmen had a little bit of a head start. So she didn't start at the origin, she started at 0,3. 5E, which runner's distance to time was proportional? Well, that would only have to be Allison because Allison in 5A had the straight line and she also started at the origin. So Allison was the only runner who had a proportional relationship.